go through here. So the first one I have is with calculating pH. It's actually a formula involving logs. I would not require you to memorize this formula. So if I put a pH question on the test, I will give you the formula along with it. So pH is just the opposite of the log of H3O+, which is the hydronium ion concentration. So in this problem, if I said find the pH of a solution with H3O+ equal to 2.5 times 10 to the negative 4. Okay, you have the pH formula. Opposite log. And this H3O+, what am I replacing it with?
2.5 times 10 to the negative 4.
And so this is just a matter of plugging it into our formula. So I tried to put at the top of your paper all the 4 different calculations we'll do. The pH one, I've typed that formula up for you already, so we're on example 1 here. So we just type in negative log button on the calculator, 2.5 times 10 to the negative 4. pH is typically rounded to 1 decimal place. So if you do that, you get a pH of 3.6.
How come those are in brackets? Instead of like brackets?
It could be parentheses.
Okay, I didn't know if that made a difference.
No, brackets are just acting as a parenthesis there, so either one is fine. Alright. Part B says find the hydronium ion concentration of a solution with pH of 7.1. So here, if we look at our pH formula, this is the formula that we are given, and you never have to memorize it. But what I told you this time was the pH. So I'm trying to solve for this H3O+. How would I get that by itself? Divide the negative over. Okay. Now it's just a log equation. So we should know from our homework, if we have a log on one side, what do we do? Exponential. So it'd be 10 to the negative 7.1 equals H3O+. Technically that is correct, but if you are like doing it on Math Excel, it's going to ask for it in scientific notation because that is the standard here. So we're just going to type 10 to the negative 7.1 on our calculator. And you will notice it gives us this really long decimal, and then at the end says E negative 8. So what that's saying,
How'd you get E negative 8? I got a long decimal that's 79.
On the graphing calculator I got it.
on the graphing ones, it gives you the scientific notation. On these, it will depend on how many digits. If it's enough digits, it'll give it to you scientific notation, otherwise it won't. Scientific notation, you have 1 digit in front of your decimal. So if you're looking at the graphing ones, it's just 7.9. If you were looking at the others, you have to move your decimal over. So you would count how many places you have to move it. 1, 2, 3, 4, 5, 6, 7, 8. And if you're moving it to the right, that is the negative. So that's, you kind of have to put it in scientific notation yourself. The graphing ones, it gives you the really long decimal, and then at the end, E negative 8, so it tells you 10 to the negative 8. So either way, we can answer it in that scientific notation.
You said that's how they want it on Math Excel.
I believe so. I'm trying to pull it up, but I'm pretty sure it does ask for it in scientific notation on on these. Any questions on that one? Yes, it does ask for scientific notation automatic, so. Alright. The second situation that we might see it is with exponential growth and decay. So that is talking about how much of a substance is left at a given point in time. So you see this a lot in like carbon dating is one situation where it comes up if they're, just really interested in fossils, you might see it there. So A of t equals a sub 0 e to the negative kt. A sub 0 is representing the beginning amount. Actually, let's not put the negative on the k. You can actually do it either way, but I already made a note down here if k was positive or negative. Let's just do regular k. And that's one less thing to worry about. I would give you this formula. K is just a constant. T is representing time. A of t is your ending amount. So if your k is positive, that would be growth. You are gaining over time. If your k is negative, that is decay, where you have less as time goes on. Does everybody have the formula down? Again, this formula would be given to you. You just have to be able to use it if I give you a question. So let's look at a question. If 800 grams of a radioactive substance are present initially, and 2.5 years later, only 400 grams remain, how much of the substance will be present after 4 years? So, this is our growth and decay. We have less of it as time goes on. So is k going to be a positive or a negative number? Negative, because the amount is decreasing over time. All right, we have to look for anything we know right off the bat. A of t is our ending amount, so that's what we are trying to find. A sub 0 is our beginning amount. Do we know how much we begin with?
800 grams.
So I know already it's 800 e to the kt. All right, now what we have to do is find k. So we are going to use this other information to do it. In 2.5 years, we have 400 grams. So I'm trying to find my constant, but we know in 4.5 years we have, or in 2.5 years we have 400 grams. So the ending amount is 400. I don't know this k, but the time that took was 2.5. 2.5 is my t, 400 is my a. Can we solve this equation for t? Oh, I thought you were volunteering. Tell me what to do first. What would we do?
What'd you say again?
How would I solve for, I said t, but I meant k. What would we do to get k by itself? Divide the 800. K times 2.5, I'll write that as 2.5. Alright, how do we solve these exponential equations with ease?
Put it out.
Ellen, you try. So then we can divide our 2.5. Let's type this in. I'm usually 3 to 4 decimal places. On your Math Excel, it'll probably tell you how many at once. So when I do that, my K is negative 2 or 0.2773. So my actual equation is 800 e to negative 0.2773 t. So all of that work was to figure out what the constant was, what the K is.
When your T before though?
That can change, the time can change. So now, once we have the equation, we can go back and answer how much will be present after 4 years. So now we can plug in that 4. And I get 263.86 grams remaining. Any questions on that? I want you guys to try the next one. So see if you can set this up. So what is my starting amount? My A sub 0. 600. I know you guys aren't done, but let's make sure we're on the right track. What we have to do before we can make our equation work is we need to know the constant. We have to find K. So that's the work we need to do now, is find out what K is equal to. And to do that, we use the other information I gave you. In 3 years, 300 grams remain. So 300 equals 600 e to the K times T, which is 3. This is a lot of times called the half-life, how long until you have half of what you started with. So you add your natural log. We know a natural log and an E cancel. Divide by 3. So natural log 1/2 divided by 3, and you get K to equal negative 0.2310. Did you guys get that? And why is it negative? Because we have less as time goes on.
So why does the 8T not have, why do you not have time next to 8T?
Oh, this is just function notation, just kind of like f of x. It's the same thing as your y. So now I want to know how much we present after 6 years. So to find the amount in 6 years, plug in a 6 for the t. And we get 150.04 grams. Is that okay? Some other situations where we might have logs come up are in interest problems. That's not anything new. We've seen the interest formulas before. Remember, we had compound and continuous interest. So I did put those on the front of your notes handout just so you had those formulas again in front of you. Just like before, they would always be given to you. So if I said, how long would it take for the money in an account that is compounded continuously? When you see continuously, which formula are you using? Okay. At 5.75% to double. So we want how long? We're looking for time. My rate is 5.75%, so 0.0575. If it's doubling, did I tell you how much we were starting with? So pick an amount. How much do you want to start with? 200. Then if I double it, I would end with 400. So we would solve some of these problems before, but I was always asking you to solve for a variable that wouldn't require a log. Now if we want to solve this, we divide our 200 over. Then what would we do?
What element?
Okay, missing element we drop. So we divide our 0.0575. And get our 12 to be, or time to be 12.05 years. Questions on that? And the 200 and 400, we just made up those numbers because it said it had to double. So you could make up whatever number you wanted for P, your starting amount, and you just double it to get your A. So if you started with $10, you would end with 20. If you started with $50, you would end with 100. One more interest one. So if I said, how long will it take $1,000 invested at 2%? So 1,000 is the amount I have right now. What variable is that? 2%, so my rate would be 0.02. Compounded quarterly, how many times a year is that? And it grows to 2,700, so that would be my A. I'm looking for how long, so time is the variable we are solving for. Since this one isn't continuous, it's the other formula. A, what is our ending amount? Equals P, what's our beginning amount? Plus R would be divided by N to the N times T powers, 4T powers. Alright, where would you begin here?
$200,000.
So you get 27. Let's go ahead and work inside that parentheses. So 1 plus 0.02 divided by 4 gives us 1.005. What do you do at this point?
Probably make that one.
Don't you divide the 1.005?
Well, it's taken to a power. So if we can't get a common base, what do we add if we can't get log? So the 4t would come down in front. And so now, x is multiplied with, or t is multiplied with all those things. So you just divide them. So we have log 27 divided by 4 log 1.005.
Isn't it 0.27?
2.7, isn't it? Did I drop a decimal? Thank you. Alright, and what do we get?
I got 49. A lot of years
It is. It's pretty,
for $2,700.
not the best setup. Alright, are these okay? Last thing I want to talk about is change of base. I know there are ways on some calculators, not all, to put in logs of different bases. But every calculator has a log and an ln button. So those are the only ones that I'm going to say you can do on the calculator. If you have a different base, like log base 2, then what I'm going to say is you have to show me the work for how you get it. And so in those cases, we use what's called the change of base formula. So, I think that's on the front of your handout today. Yeah, I already typed it in for you. You don't have to write anything. So you can change it to whatever base you like, which in our case is usually log base 10 or log base e, of the argument divided by log of the current base. So for example, if I ask you to approximate this with 4 decimal places, if I put this on a test or quiz, just to keep everything fair for those that have calculators that do it versus those that don't, I would tell you, you have to show me the work for the change of base formula. And so what you do is log of the argument divided by log of the base. The reason it works is if you change it, set to x and change it to exponential form, it's like saying 5 to the x power equals 7. And if you were solving that, what would you do?
X log 5, log 7.
And then you divide your log 5. So that's where the formula comes from. It's not anything we haven't already been doing, just a more direct path. So then you can type that in, log 7 divided by log 5, 4 decimal places, so 1.2091. Alright, and we always change to log base 10 or natural log because those are the 2 buttons we have. Did you guys get those? Okay. What would I write for B?
Log of 0.1.
And we get 3.3219. Any questions from this stuff? is a math Excel assignment.